Well, good afternoon, friends. Dr. Jim Daly here again for this week's Sky Tonight. Tonight we're going to, this afternoon and tonight we're going to start taking a look at some things, some objects specific to the summer sky, some constellations specific to the summer sky. Okay, during the year we use, as you know, we're using Stellarium. And what we're going to do, the moon is now approaching third quarter, which means it rises well into the night, almost at midnight. And the sun, take a look here, is setting just about, take the land away, you can see the sun is right there. We're going to put the sun right on the horizon, and with Stellarium, we can actually determine when the sun sets. See, take a look. The sun is just at the horizon now, the western horizon, and it's now, it's not quite 8 p.m. It's 9:57. Excuse me, 7:57. Okay, not quite 8 p.m. So that's when the sun is setting. As we know, the summer solstice passed us back in June on the 21st, and the sun reaches its highest elevation in the sky for the year. And every day after that, to the autumnal equinox, the sun is very slowly, very gradually moving further south in its path when it sets. Okay, so let's take a look at what the sky looks like just as the sun is setting now. Stars just beginning to come out. First stars to come out we can see here. This is Leo. We talked about Leo in a previous video. Leo and Virgo, this is Spica over here. These are springtime constellations and stars. And we can just put up the constellations here. You can see Leo and Virgo are there, and they're going to be gone probably by 10 o'clock. So if we want to take a look at them, we have to do it quickly. Okay, as the summer moves on, as the days and weeks pass, these constellations of spring won't even be visible anymore. Okay, so let's continue looking towards the east. And we see Jupiter, mighty Jupiter, with Scorpio and Antares, which we spent some considerable time talking about in the star Antares right here in the previous video, so we're not going to talk about that this evening. We're going to concentrate on some more objects specific to the summer. So let's continue our sunset as the sky gets darker. More and more stars begin to come out. You can just start to see the Milky Way coming out. The Milky Way, the summer skies. Big hallmark of the summer sky is the Milky Way. What the Milky Way is we're looking through the we're looking horizontally through the plane of our galaxy, our home in the universe. Look out beyond our galaxy, we see hundreds of billions of other galaxies across vast distances of space and time. And we're in one of those galaxies. In our home, it's called the Milky Way. Okay, so the sun is pretty much set by now. And you can see Milky Way just beginning to come out. Here we go. And if you look here, it's the famous, any astronomer, amateur, professional knows when you look to the south during the summer months, you can see the beautiful constellations of the summer sky. You have Sagittarius here. The Archer looks like a teapot. And we have Scorpio, which we talked about previously. Now, what we're going to do here, the summer sky is extraordinarily rich in objects, in a treasure trove of star clusters and untold thousands and thousands of stars to see, even with a modest pair of binoculars. So there's a lot to talk about. With each one of these videos, we're going to concentrate on 2 or 3 aspects of the summer sky, or each seasonal sky, I should say, as we go further and further into the year. Each season brings or has its own unique targets to look at, each equally magnificent to understand and look and observe. Okay, so the sky, this is the sky tonight. It's just shy of 10 p.m. It's 10 minutes to 10 here. Okay, so the sun is set and we're in a comfortable position, facing due south. We see Scorpio and Sagittarius, well placed right here in mid-northern latitudes. Now, it's one thing we won't get into tonight, but you should remember that with Stellarium, we can travel to any point on the surface of the planet and take a look at the sky, what it looks like at that, at that location. So right now we won't explore that aspect of this software, but we will come back to it at a later date. Okay, so what I want to do now is we're going to turn off the atmosphere. Just do that now. Okay, here's the atmosphere. That's the planet, but here's the atmosphere. Now look what happens. We take away the atmosphere, the brilliance of the Milky Way just jumps right out at you. Right, you see mighty Jupiter here. We talked about Jupiter at the beginning of the month in our video of July 8th, a couple of videos back. So we're not going to take a look at that. And Saturn over here, if you have a small telescope or a pair of binoculars and you look at Jupiter and Saturn here and understand that 25,000 light years further out towards the center of our galaxy, this is what we see. Okay, so this is not only an exercise in appreciating the physical beauty, but it's also a deeper aspect to this by understanding the depths of space and time involved. So when we look across these distances of space, we're looking back in time. So that light we see from our galactic center right here left it 25,000 years ago. So our ancestors, our distant ancestors, 25,000 years ago, when they were just finding their way, figuring out how to survive, the light that we see tonight left that center, the center of our galaxy. It's just arriving tonight for us to observe. Okay, so let's travel north. We're going to travel north along the Milky Way here. And in a previous video, I believe it was also in that July 8th video, we talked about an asterism. Mentioned that an asterism is a familiar pattern of stars, that our imagination, our mind sees. That's easily recognizable. And this one is the famous summer triangle. Is Vega, Deneb, and Altair. Now, as in the previous video, we had Arcturus, and we studied Arcturus and Antares in considerable detail. And there's another object lesson here in this asterism too, as well. I'm just going to briefly mention it. This is the star Deneb. Deneb is about 2,000 light years away. Let's check. I believe it's 2,000 light years. Distance, beg your pardon, it's about 1,500 light years. Okay? Now you take a look at Deneb, and then we take a look at Vega. Vega's about 38 light years away. Okay? Distance, beg your pardon, it's 25 light years. Okay, so why is it that these two stars of comparable brightness, where one is almost over 40 times further away, Deneb, than Vega, but yet they're the same brightness? Again, this is an object lesson in stellar luminosities. Deneb is an enormous star. It's a blue-white supergiant. Again, it's a helium-burning star. It's depleted its complement of hydrogen in its interior, and it's now expanded to tremendous size, and hence its luminosities increased tremendously. Don't forget, the luminosity varies as the fourth power of the temperature, right? And the second power of the size. So since these two stars, Vega and Deneb, are comparable in temperatures, the governing factor in this particular difference then would be its size. Deneb is tremendous. Okay, and it's well on its way to ending its life in a spectacular fashion, as was Antares, as a Type 2 supernova. Okay, so let's take a look at that now. All right, I want to zoom in on Vega. I don't know if anyone remembers, but an excellent movie was before the year 2000 was produced called The Contact. A lot of people refer to Vega as the contact star because that star was the object of the object of the movie in a sense, where all of a sudden an intelligent signal with very deep, complex aspects to it was received, and contained within that signal were instructions how to build a machine to travel to Vega, forward or backwards in time. It's a tremendous movie, and it started everybody thinking a lot about this. Anyway, that's the contact star. Now, if we do, let's take a look at Vega more closely. To do that, we're going to zoom in. Okay. All right, so now let's just move the sky a little bit. This is the whole constellation of Lyra, the harp. Now, the ancients, lived thousands of years ago, and when we look at this grouping of stars, we don't particularly see a lyre, which is a harp. So let's just use stellarium for a moment to get a sense of what it might look like. See? That's a harp. And this is what the ancients saw, the Greeks and the Romans. Specifically, this would be the Greeks. They looked up and they saw these patterns on the sky. All right, and today in modern astronomy, we honor their contributions to science and astronomy and mathematics. In one of those honors is we maintain the lore, or the histories and the story and the mythology behind these constellations. Okay, so this is Lyra the harp. Now, if we were to scan this region of the sky with a pair of binoculars, this is more or less what we'd see. This is how it would look like in a pair of 10 by 50 binoculars. And if we look here, zoom in on this section of the sky here, between these two stars and Lyra, look what we have here. A tiny little smoke ring. Look at that. That's what we call a planetary nebula. Planetary nebula is an object that represents the end states of stars like our sun. We've spoken a lot now about big stars, stars with high mass, how they end their lives in a tremendous, spectacular fashion called a supernova. This is not so spectacular, okay? What happens over time, the helium burning process, the helium becomes depleted, and then the product of that helium being built up over the hundreds of millions of years in that process was carbon and oxygen. The star lacks the mass to continue that process, fusing heavier and heavier elements from light elements. So what happens is it continues expanding, and what's left over deep down in its core inside here is a white dwarf star. Now, this particular planetary nebula is called M57. M stands for Messier. Charles Messier was a 19th century astronomer, French astronomer, who was cataloging these non-cometary objects that were not comets. This man, Charles Messier, was a comet hunter. He liked observing comets. So he created an exclusion list. That exclusion list today we call the Messier catalog. And this is number 57 in his catalog. So we would know, he would know, whoever would use his catalog would know, if you're looking for comets, this is not a comet. Okay, so that's Messier 57. You see the central star here. We call that the central star. It's a white dwarf star. A white dwarf star is no longer producing energy such as the sun is today, but it's still enormously hot, tremendously hot, and over billions of years will slowly radiate its heat away, become just a cold ember in space. Okay, and this beautiful gas ring we see will have dissipated long ago. All right, so that's the end state for stars like our sun, not a supernova. The sun does not end its life as a supernova. Now, I'd like to share with you something that I did a while ago here. Okay, here we see that same ring right here as a ruby red, small ruby red ring right here. This is the view you would see through a small Richards-field telescope, an amateur telescope, or a very powerful pair of binoculars. Probably not binoculars, you would not be able to see it quite like this. This was taken with a wide field, what they call an astrograph, a telescope that's been converted into a camera. Okay, we can zoom in on this a little bit. Zoom in. You can start to see a ring emerging there. See? Okay, this is with a wide field telescope. Okay, go back to the standard view now. Spectacular view of this is here. We zoom in on this. This is what we see. This is the image. This is the same object image with the Hubble Space Telescope. Fantastic orbiting observatory. It's been pushing back the frontiers of knowledge, science, and our understanding of the universe since 1991. Okay, it's been its value and its price cannot be. Its value you cannot put a value on this telescope. Its contribution to our understanding of the universe and the science of astronomy, astrophysics, and physics also has been enormous, has been immense. Okay, that's what the Hubble Space Telescope. So let's go back to Stellarium. Okay, we were looking at, this is a depiction using existing data. That's how we were able to do this. Stellarium integrates existing image data from orbiting telescopes, from any various telescopes and observatories. And this particular image is also from the Hubble telescope. If you take a look at this and you take a look at that, images are similar. All right, so this image superimposition on the star fields in Lyra, that image, you can get a sense of how small that is. Okay, and how far away it is. Its distance here is about 3,000, not quite, it's about 2,900 light years away. Okay, so the light we see from that star is not quite 3,000 years old. So, give you a sense of the distance involved here. Right, so that's Lyra. Field around. And zoom back out. This is our view as we saw. If we could see it with a nice pair of binoculars, that's what it would look like. We use center Vega here. That's what we would see. Okay, so what I'd like to do now is we'd like to segue to Constellation of Hercules. So in this, if we put our constellations back up, the artwork here. See, Hercules is just to the west of Lyra, right up here. Okay, and everybody knows who Hercules is, right? We don't have to describe Hercules. He's one of the chief gods in Greco-Roman mythology, right? Let's take a look what his shape looks like. You see, he's like a keystone. They call this the keystone of Hercules. Okay, and if we zoom in here, zoom in on another one of these amazing objects, similar to what we looked at a couple of weeks ago in Scorpio, right here. This object is another globular cluster called Messier 13. This is number 13 in the Charles Messier's catalog of non-cometary objects. Right here. It's an agglomeration of hundreds of thousands of stars, all bound together. These stars date from the very beginning of the universe, some of the oldest stars in the universe. And these objects basically have similar properties and populations of stars. So the description we gave for Messier 4 in Scorpio would apply to this one too. So let's take a look at, if we were to scan this region of the sky, although we can see what it might look like with Stellarium, there's a real image I produced a while ago of what it would look like in a pair of binoculars or small amateur telescope. In this case, it's the same instrument that produced our wide field view of the ring nebula, Messier 57. So let's take a look at that. Okay, we'll be right here. All right, so that's Messier 13, as seen through a wide field astrograph, my own, produced a number of years ago. These objects are so far away, the stars, the ages of these stars, and their time scales in which they live and evolve and so forth, don't matter in a human lifetime. Nothing really changes. So this is going to look the same way in 1,000 years as it does tonight. So that's what it looks like through a wide field telescope, a visual view. This is what it would look like. Let's take a look at what it might look like through a larger telescope. You could zoom in on it. That's what it would look like. All right, you can see these two stars here. This one is more of a yellow-orange. This one is a bluer cast. This is a hotter star than this. Okay, stellar color is an indicator of the star's temperature. Cooler stars tend to be red, orange, or yellow. Yellow being the warmest of those. Hotter stars, more massive stars, tend to be blue-white or white. Okay, blue being the hottest and the most massive. Okay, that's Messier 13, and here is an interesting assortment of images taken with the Hubble Space Telescope. This is the core of M13. Okay, zoom in on that. Because of the size of the Hubble telescope, you're not going to see this image the way you saw it here. Okay, previously. This one. This is what it would look like through a very good large amateur telescope. And with the Hubble telescope, because of its size and narrow field of view, we're just going to see the inner part of it, or the core of M13. And these stars here, we talked about this previously too in an earlier video. These stars here that look orange and red but bright, these are stars like Arcturus, similar to our sun, red giant or red supergiant stars, but they're so far away. This object is 25,000 light years away. I'd like to point out, a moment ago I mentioned that those bright stars, those brighter members of the Scorpio clusters, Messier 13, I mentioned that they're like the sun. They're like the sun in its end state. I want to be clear on that, okay? That could be confusing. Okay, these stars, there's a lot going on here in terms of what we're trying to describe. Looking back, of course, vast distances of space and time, and in the lives of these stars, these hundreds of millions of stars that have been living and dying for enormous lengths of time. All right, so let's go back. I just want to clarify that. Okay, let's go take a look at, this is Hercules again. All right. I did mention that these objects are between 20 and 25,000 light years away, and Stellarium does record the distance for you. Okay, take a look here. There we go. Okay, distance is 6,800,000, 6.8 kiloparsecs, or 6,800 parsecs. A parsec is a little bit 3 1/4 light years. Well, that puts this object at 22,000, almost 22,200 light years away. So the light we see from this object tonight left its 22,000 years ago. That's what we see tonight. Okay, let's return to our normal view of Stellarium. It's the keystone of Hercules. We're zooming back out. Okay, here's a normal view. Now, don't forget I've turned off the atmosphere in here, so this is not the sky that you would see in the normal view. This is the sky you would see perhaps out in the desert, or maybe even from the dark side of the moon, but you would never see this in the populated area, or the city area, light pollution, and so forth. This is not the sky you would see. You would see this out in the middle of the desert, maybe out in the middle of the sea, out in the middle of the Pacific Ocean. This is kind of the sky you would see there. Okay, so let's take a look towards the east. Now this is just past midnight. It's 12:37 a.m., July 23rd. And what do we have here rising in the east? This is what, everybody? This is the moon. This is the third, this is not quite third quarter. This is a waning gibbous moon. Waning means waning in phase, not in size. Okay, waning in phase. It's approaching new moon. Okay, let's zoom in on it. Stellarium allows you to do this. Let's take a look. Okay, Okay, this is the view of the moon you would see through a very good pair of binoculars, perhaps a 10 by 50 pair of binoculars or a small telescope. Okay, we zoom in. Detail and the resolution are pretty good. Again, this is what you would see through a modest amateur telescope. Now, I took an image a few years ago of this particular phase of the moon, a third quarter moon. Let's zoom back out. Okay, this is a 25 centimeter, it's about 10-inch diameter telescope in the same phase of the moon. Okay, if we zoom in at 50%. Okay, this is what you would see. Very good, good resolution telescope. This particular telescope can see at the distance of the moon. You would be able to resolve something about 1 kilometer in size. So this image or this view is at the resolution limit of the telescope. So if you see this detail in this crater here, you can see this central mountain here. And look at the detail in the crater wall. It's pretty good detail. It's exquisite, actually. You can zoom in a little bit more. The image is that good, we can actually enhance it even more. Zoom right in. Okay? That's approaching pretty much the resolution limit for this image. Okay, zoom back out. And this is a third quarter moon. Here, we just finished celebrating, speaking of the moon, we just finished celebrating the man landing the moon back in July 21st, 1969, of Apollo 11, 3 astronauts, 2 of whom are not with us any longer, Neil Armstrong and, oh no, beg your pardon, Neil Armstrong is the only one who's gone. Buzz Aldrin is still around. He was the companion to Neil Armstrong. The 2 of them set foot on the moon. And we had Michael Collins. He was interviewed last week on the 16th with the launch. July 16th was the 50th anniversary of the launch of the mission from Kennedy down in Florida. So 2 out of the 3 are still with us. Sadly, Neil Armstrong is no longer here. He was the first to set foot on the moon. In the Sea of Tranquility. Okay, July 21st, in the wee hours of July 21st, just after midnight on 1969. Okay, let's go back to Stellarium. Zoom back out. Okay. The stars we see here now are the stars of the fall. And since we're very late into the night, right now it's almost 1 a.m., it's 12:40, we're going to begin to see the stars of the fall coming up. This is the Great Square of Pegasus over here, and so forth. So we're not going to take a look at that. Here's Aries, actually, the constellation of Aries. And Pegasus over here. It's the Great Square of Pegasus. Briefly put that up so we get a sense of what it looks like. Okay, and there's Pisces, there's Aries, and Pegasus with Andromeda over here. So these are some of the things we can look forward to in the fall. Okay. A lot going on there. Okay. All right, so let's put the atmosphere back, get a sense of what it might look like later in the evening. Let's advance the sky, listen to some music as the sky moves forward towards the next day. Looking southeast. This is the lone star over here, Fomalhaut. Here, it's fairly close. Distance is 25 light years, similar in distance to Vega. That's the star Fomalhaut. Okay. This is 2 a.m. in the morning. Okay, we're gonna. Okay, and we have our sunset be the following morning. Okay, and this is what we'll look at sunrise tomorrow morning. Okay, with the sun just beginning to come up above the eastern horizon, the northeast over here. Okay, so anyway, everybody, I hope you enjoyed this video. If you liked it, if you find it useful and helps you learn, please do like and subscribe. Our homepage, our public website is astronomyforchange.org. And membership is always free here at Astronomy for Change. Simply go to our homepage, click the red tab, fill out a few details, and you'll begin to receive our newsletters. We're going to begin a pilot program pretty soon. We're going to offer courses, astronomy courses, and details will follow in the newsletter that will be coming up soon. Please look for that, and in the meantime, everybody keep looking up, and thank you until next time.